solve third problem. The third problem goes like this. Air enters the first compressor stage of cold air standard Bryton cycle with regeneration and intercooling at 100 kilopascal, 300 Kelvin, and mass flow rate is 6 kg per second. The overall compressor pressure ratio is 10 and pressure ratio is same across each compressor stage. The temperature at the inlet to the second compressor stage is 300 Kelvin. The temperature at the turbine inlet is 1400 Kelvin. The compressor stages and turbine isentropic efficiency are 80% and regenerative effectiveness is 80%. So calculate power developed in kilowatt and thermal efficiency of the cycle. So basically this is the problem which involves compression in two stage. Okay, so there is intercooling. So inlet temperature is of the air is 300 Kelvin. Okay, here you can see, and the turbine the second compressor stage is the temperature at the inlet of the second compressor stage is 300 Kelvin. Okay, so the temperature at second stage inlet is same as the first stage inlet, you can see here. Okay, so you have to calculate the power developed in kilowatt and thermal efficiency of the cycle. Isentropic efficiency of the compressor and turbine is given to you, and regenerative effectiveness is also given to you. There is a regenerator also. Okay, so if I draw the thermodynamic cycle, Bryton cycle for this particular problem, it is something like this. This is T axis, this is the S axis, entropy axis. So this is stage 1. First stage compression takes place from 1 to 2s. This is isentropic process, and 2 is the actual process. So again intercooling takes place over here. So intercooling takes place from 2 to 3. Okay, at 3 the second stage compression occurs, and the second stage compression is from 3 to 4. This pressure line is 100 kilopascal, and there is a pressure ratio of is given to you. Pressure ratio of 10. Overall compressor pressure ratio is 10. So here is 100 kilopascal. So here will be 1000 kilopascal. Okay, and you have to find out the intermediate pressure. Now this is the problem which involves the regenerator. The temperature at this point will be x, let's assume. Okay, in ideal case this Tx will be equal to T6. Okay, and the heat input will be from Tx to T5. Okay, now this T3 and T1 will be equal. Okay, because second stage, you can see here, the temperature at the inlet of the second compressor stage is 300 Kelvin. So T1 will be equal to T3. So accordingly you have to draw the diagram. Okay, now if I assume, or if we assume the perfect intercooling, P2 we can find out under root of P1 and P3. So you get P2, that intermediate pressure as 316.22 kilopascal. Okay, now usual procedure, I will get the temperature T2s. Okay, so how to get T2s? T2s upon T1 is equal to P2 by P1 raised to gamma minus 1 upon gamma. This is the usual procedure we have followed in the last problem. So you get T2s as 416.85 Kelvin. Okay, now to get T2 I will take the help of compressor efficiency. Compressor efficiency will be equal to T2s minus T1. So T2s minus T1, this is the isentropic process, upon T2 minus T1. So that will give you T2. So if you calculate T2, it will be 446.1. Now since the pressure ratio is same for each compressor stage. Okay, so from first to 2 and 2 to 3 the pressure ratio is same. So T3 has to be equal to T1, and therefore T4 equal to T2. So this T4 will be equal to T2 because the compressor ratio is same in both the stages.